In this video, we'll discuss measures of variation. Now, we've talked about mean and median, and one of the things to recognize is that those are only part of what we need to understand from a set. For example, if I look at all three of these sets, they will have the same mean and median, which is 13. However, there's a lot of variability in these sets, and that changes some of what we understand means from these three sets. And because of that, we want to also be looking at things like the range, the variance, and the standard deviation of a set. So when we talk about the range, this is the easiest variability to understand because we're only looking at the difference of the smallest and the largest value. It's important though to order your data so that you can find those two values quickly. It doesn't matter which way you go, smallest to largest or largest to smallest. Now when we look at the three sets we just had, they were already in order from smallest to largest. So I could take the first and last value and subtract them. So in set 1, the range was only 4. In the second set, that range was 24. And in that third set, the range was 28. So even though they had the same mean and median, there's a lot of range within the data to create those two central tendency measures. And that's where we start looking also at our variance and our standard deviation. Now, when we're talking about these terms, variance and standard deviation, we got to understand what do they mean. The word deviation is talking about the difference between an entry value and the sample mean. And when we're talking about the sample variance, what we're going to do is average the sum of the squared sample deviations. Now, if that's a small variance, we know the data is relatively compact. There's not a lot of variability from one data point to the next. Whereas when the variance is large, that means our data is very spread and there's a lot of variation in the values that created that mean and median. When we calculate, we can use a program like Excel or Google Sheets or even a graphing calculator. And when we do that, we're going to use this statement of var.s, and then we're going to highlight our entries. Now, you'll also see sometimes var.s and var.p. And you have to pay attention to what is the entries you have. Is it all the population, or is it a sample that you took of the population? We use .s for samples. We use .p if we have the entire population's information. Now, if you need to manually calculate a sample variance, what we're going to do is first determine our mean. Then we're going to take each entry and subtract the mean. So some will be positive and negative. We're going to square each of those values so they all become positive values. Then we're going to add those squares together and then average them by doing n minus 1. And that minus 1 has to do with the fact that it's the population, or it's the sample, not the population. So if I take my very first set, we said that the mean was 13. So I can take each individual entry and subtract 13. So 11 minus 13, I'm going to do that. Then the 12 minus 13, the 13 minus 13, the 14 minus 13, the 15 minus 13, the 15 minus 13. And I have now these 9 values. I'm going to square each value. So each of these negatives now becomes a positive. So positive 4, positive 1, 0, positive 1, and positive 4. Now I add them all together. So I'm going to sum up. I'm going to add all 9 values and then divide by 9 minus 1. So that when I add these together, I get 20 over 8, which is 2.5. And when we write our variance and our standard deviation, we will be rounding these to the decimal places. So just pay attention to what a problem may ask as to how many decimal places is needed. Now, if I want to do this on a spreadsheet program, let's look at the second set. The first thing I'm going to do is I'm going to have my entries. I need to make sure they're in a column together. Then I'm going to go over and I'm going to type in an open cell, the equal sign, and then var.s. And normally you'll see something pop up here. And as you start to type it, if it's what you want, you can always just click on it and it'll let you start that program. Now I'm going to highlight all my data. And I should see that the cells A1 colon to A9. I could manually type that in, but highlighting is often a pretty nice thing to do. I'm going to close my parenthesis and then I'm going to hit enter, and that'll give me my variance. So the variance for set 2 is 74 and 25 hundredths units. Now the standard deviation represents the spread out of all the values of the entries compared to the sample mean. It gives us an idea of how much spread there is. This is what you often hear, like in polling, they talk about some percent and then plus or minus some value after that. That's the standard deviation. And the way we calculate it manually is we just have to take the square root of our variance. So if we think back to our set that we had with set 1, we said the mean was 13, the variance was 2.5. So to get the standard deviation, I take the square root. That's an irrational number, so I'm going to round it to probably 1 or 2 decimal places most commonly. In this case, it'd be 1 and 58 hundredths. So the standard deviation, or the average deviation from the mean, they mean the same thing, is about 1 and 58 hundredths units. If we wanted to use a spreadsheet program, let's take that second set. We just have to use the term stdev.s. Standard, we've abbreviated to st, deviation abbreviated to dev. So I have my data. I'm going to enter in an open cell equals stdev and make sure it's the .s if it is a sample. I'm going to highlight my data, and then I'm going to close my parenthesis and hit enter so that I can see here that my standard deviation is about 8 and 62 hundredths units. So whether I do it manually or I do it with the spreadsheet, I'm getting the same values every time, and that's important to recognize. So if I look at all three sets, again, they all three have the same mean, but it's where my variance and standard deviation changes that's the important part to recognize. In this first set, my values are from 11 to 15, and they're all really close together, so my standard deviation is really small. As I look at as my values spread out more and more, my standard deviations become greater as well. So just because I have the same mean doesn't mean I'm going to have the same standard deviation, because it's looking specifically at the spread of all that data. So again, remember, variation focuses on the spread, not the actual numbers. The numbers really don't matter. It's about the spread of those numbers. So to make a point of this, say that I take my very first set there, the one that went from 11 to 15. I know here are my mean, my variance, and my standard deviation. Say that now I take that same set and I add 50 to every value. So now I'm looking at 61, 61, 62, 63, 64, 64, 65, 65. So my mean will change. My mean now becomes 63. It's 50 units higher. However, let's look at the variance and the standard deviation. If I use my program, I'm going to put in all my data here, the first 9 cells. I'm going to use the var.s for my variance, and I'm going to highlight it and push enter. It's still 2.5. And when I do my standard deviation and do this stdev.s, and I then highlight my data, close my parentheses and hit enter, I'm getting the same value again of 1 and 58 hundredths. So again, the entries have different values, but the spread within those entries is exactly the same because all I've done is add 50 to each of them. So it doesn't matter what the numbers are, variance and variability always focuses on the spread of that data.